Hello and welcome to the section 5.4 lecture. Today we are talking about graphing lines in slope-intercept form, which is probably everybody's favorite, mainly because it's typically the first one that we learn, and it's one of those forms that you don't have to do a whole lot to, and it gives you a whole bunch of information. So if we remember something like the point-slope form, where we had y minus y1 equals slope times x minus x1. If we have that form of the equation, we had to look at what the sign and the value was here, and remember that we're looking for the opposite of that. If this was a -5, we would have a y value of 5. And then we also had to remember, okay, the first number they give me is going to be a y value, and the second number, the last number that they give me, is going to be an x value. So we had to remember all that stuff, and it was useful. It just wasn't quite as beneficial as it could be, and in fact, not as good as slope-intercept form gives us. Okay. Slope-intercept form is written in the form y equals mx plus b. Most people remember that from earlier classes, where the number multiplied by x is my slope, or m is my slope, and b, or the number that's added or subtracted, is my y-intercept. Okay. Interestingly enough, if we had an equation in point slope form that was given, that gave us the point, let's say we had the point, let's use an actual example here. Let's say that the slope is 1/2 and it goes through the point 0.05. Okay, well, the point 0.05 we should realize is a y-intercept because it doesn't have any x value to it. But what happens, what does that look like in point slope form? In point slope form, I have to remember, okay, well, I need that opposite of my y value, so I'd have y minus 5 instead of plus 5 equals m is 1/2, and the slope, and the x minus 0 here. Okay, well, kind of processing this and simplifying this a little ways, this is going to give me x minus 0 is just x, and 1/2 times x is just 1/2 x. So I would get y minus 5 equals 1/2 x. And then if I just move this 5 to the other side by adding 5 to both sides, now it's something where I have 1/2 x plus 5 is now in what we call slope-intercept form. Okay, so that's a good little thing, and we notice everything stays the same. I have a slope of 1/2, and going through the point 0.05, meaning it has a y-intercept of 5, that's shown right here. And I don't have to think about the opposite of this value or anything like that. It's just that number. Okay, we're not really looking at writing, but that's just a quick little example of kind of where slope-intercept comes from, and it's really just an extension of point slope form. And that's why we go over point slope form first, because this slope-intercept form comes from that. But how do we use it? So we're going to say that we have our y equals mx plus b, where m is our slope and b is our y-intercept. So how do we use that to graph? The first thing we want to do is we do want to identify, which I've just done, but I'll show you what I mean by that in a little bit. Identify our slope and our y-intercept, or our m and our b. Why they chose b there, I'll never know. There's no b in the word y-intercept. I don't know why they chose it. They couldn't use y because we already have a y. And they wanted something important, so they needed a letter that hasn't been used for a lot of things, so they went with B. Same thing with M for slope. I don't get that either. Okay, so the second step is going to be plot the y-intercept. So plot the y-intercept, put that point on the graph. So I'm saying that my y-intercept, we're going to go right here. I'm going to say that this is b. Okay, I don't have values on this one, but that's okay. Step 3 will be plot another point. Using the slope. Let's just say that my slope is something over something. Maybe we say it's m over 1. So go up m over 1. And I get another point, so I plotted another point. And then step 4, graph the line. Now I will say kind of, I guess I could spell things right. Graph the line, sorry. Some other things that I would say here is kind of like a optional extension to step 3 is that you can keep stepping this slope out. You know, I could keep working with that same slope and step it out a ways to make graphing my line that much easier. Okay, and that's not a great line because I didn't know what m was, so I just kind of went with it. But you see, you get the picture from that. Stepping that slope out farther makes it easier to freehand a line. So looking at this in an actual example, the first thing I want to do is really say, well, my slope is 5 or 5 over 1, if that helps you, and my y-intercept is 7. So on this one, I'd be going up to 7, and I want to go up 5 and over 1. Now, I can't do that, and do make sure you pay attention to the scale on this graph. Every line's worth 2, which is great for odd numbers. So I can't go up 5 and over 1, so I'll go down 5 and left 1. But I kind of know, I'm thinking that there's a point somewhere up here. I don't know where it is, but it's somewhere up here. So let's go down 5. So we go down 1, 3, 5, and over 1. Now that doesn't mean over 1 line. That just means over 1 unit. So it's about there. We can do it again. Go 2, 4, 5, and over 1. Still don't have a good grid point, but that's okay. Let's try it one more time. 1, 3, 5, and over 1. And we get another point. So somewhere in there we have somewhat of a straight line. It's not going to be perfect because I don't have too many true grid points that I could have followed. But something along those lines would be totally passable for me. Okay, that's what I expect to see. All right, awesome. Okay, a couple other examples that we have here. It's just a good habit to get into to identifying your slope and y-intercept and think about what is the slope on this one. There's no number in front of x, but it's not 0 because then we wouldn't have an x. 0 times x would just be 0. So what times x equals x? It has to be a 1. So my slope is 1 over 1. And my y-intercept is -3. You have to include that sign. Okay, where point slope form, we had to think, okay, we got to think about the opposite of this. We're not thinking about -3. We'd be thinking about +3. In slope-intercept form, it's a little bit nicer that we treat this whole thing out here as the y-intercept, whether this sign is positive or negative. So we're going to start at -3, and we go up 1 over 1. Up 1 over 1. You can do this all day, right? Just go up 1 over 1 and see where it takes you. And it turns out that when I'm not one to typically draw on this pad a very straight line, but the closer my points are together, the easier it makes it. I say that and then I screw up. But I can do pretty well. There we go. See if you can do better. I have faith that you can. Okay, on this one I have a slope of -1/2, and I always think of that as a -1/2. And then a y-intercept of 5. So y-intercept at 5. And I'm going to go down 1 and right 2. Down 1, right 2, down 1, right 2. I can even do it this way. It makes life just a little bit easier. I shouldn't have gone this way. I can't go left very well. Oh boy. Again, see if you can do better than that. I have faith that you can. Okay, so give a quick summary of your notes. It should be pretty easy today. I would have something about y equals mx plus b on there. As far as assigned homework problems go, we're going to say practice and application. Practice-wise, for these first 6, and not that you're doing all of them, you just want to say m equals b equals. We're going to go, we'll go 1, 3, 5, and then we'll go 8 and 10. And that's the rest of this page. For application problems, let me just double check what they look like. Yeah, so we did, we're going to go 2, 4, and 5. Okay? So get those problems done, get that mastery challenge passed, and we will see you in class. Have a good day.